Here we're going to look at the technique for writing an overall redox equation. We've been given a question where we've got to write an overall equation for the reaction between dichromate ions and sulfur dioxide. I'm told that dichromate ions are reduced to chromium 3+ and the sulfur dioxide is oxidised to SO3. The key to writing an overall redox equation is firstly to write the half equations. One half equation obviously is a reduction, the other one will be an oxidation. So we're going to write the reduction half equation first. And this is a half equation I'm going to whiz through because it is one which I have covered in an earlier video titled Half Equations Part 2. So if you want to see how we got to this, you need to have a look at that video. And that is my half equation for the reduction. We now need to write a half equation for the oxidation, which is oxidising sulfur dioxide to sulfur trioxide. So SO2 goes to SO3. The first step is to balance the atoms undergoing redox. Well, the sulfur is the atom undergoing redox, and that's already balanced, so we can move on to the next step. The next step is to balance any oxygens with water. 2 oxygens on the left, 3 oxygens on the right. So now we get the following. Now we need to balance the hydrogens. We've got 2 hydrogens on the left, no hydrogens on the right. So remember that we balance hydrogens with hydrogen ions. Now this is now balanced for atoms, but it's not balanced for charge. We've got 0 charge on this side. We've got a +2 charge on the right hand side. And we need to add electrons to ensure that both sides have got 0 charge. And hopefully you can see that we need to add 2 electrons to the right hand side. You should be aware that because this is an oxidation, the electrons will always appear on the right hand side. Now I can double check that it is 2 electrons because we've got an oxidation state of 4, and that then has lost 2 electrons to give this sulfur now an oxidation state of 6. But before I can combine now this oxidation here with the reduction half equation, we need to make sure that the electrons gained, which is 6, equals the electrons lost, which in this case is 2. And they're not the same. So what we need to do is multiply this equation here by 3. And in doing so, that will give us 6 electrons on the right hand side. So if I multiply all that by 3, I get the following. So that now is my oxidation half equation, and I can combine this with my reduction half equation. They're highlighted in pink. These electrons will cancel. 6 electrons gained, 6 electrons lost. To combine them, we would simply combine the reactants from the reduction step with the reactants from the oxidation. So let's do that. So these are the reactants from the reduction plus the reactants from the oxidation. And they're then combined with the products from the reduction, which as you can see there is 2 chromium 3+ and 7 waters, with the products from the oxidation, which is 3 sulfur trioxides and 6 hydrogen ions. That there is my overall redox equation, but we've not quite finished. Any species that appear on both sides of the equation So for example, 6 H pluses there, 14 H pluses there will cancel. So these 6 H pluses here will cancel 6 of these 14 H pluses on the left, and then 14 then take away 6 gives me 8 H pluses. You can also see we've got 7 water products and only 3 water reactants. So these 3 waters will cancel 3 of those 7. 7 take away 3 is 4. So we can now write my final overall redox equation. And that there is my overall redox equation. You should always just double check that everything balances. And again, so just recap, what we've done is we've written the half equations for the reduction here and the oxidation here, ensuring that the number of electrons gained equals the number of electrons lost. Then when we do that, we simply combine the reactants and products from each half equation, and ensuring that if you do have things on either side of the arrow, you cancel. And that is overall redox equations.